Hi, welcome to the Unit 1.3 Foundations of Chemistry video. In this video, we're focusing on key question 2, how do we quantify matter? In this video, like every other video, you make sure you annotate, and there is an optional dimensional analysis video that you can watch if you need help on that, and that's in part 2. All right, we've said before that chemistry is a study of matter, and chemists study matter by observing chemical and physical changes. So let's begin this video by talking about what chemical and physical changes are. A physical change is one where the substance stays the same, and common examples of that would be phase changes, like melting a solid. So a solid going to a liquid would be melting, and a liquid going to a gas, which would be boiling. Those are all phase changes. Or dissolving a solid in water, forming an aqueous solution. So a common example would be liquid water. If we freeze it into ice, that's a physical change, because although we're freezing it, we're starting off with water and we're ending off with water. We have H2O in the beginning and H2O in the end. A chemical change, on the other hand, is one where we change the substance. And this may be something I believe you have to change on your packet, so make sure it says where the substance changes. And chemical changes are one where that's any chemical reaction. So here we have an example of water decomposing into H2 gas and O2 gas. So although on both sides of the equation we have H's and O's, or hydrogens and oxygens, H2 gas and O2 gas is not the same thing as liquid water or water, H2O. So for this first CFU, you're going to circle all of the chemical changes, and it may be difficult for you to see on your own packet. So instead, what you could do is you could just list out anything that's a chemical change on your packet. I'll read these out in case these are not clear. So this first one here is breaking a window. This is baking a cake, slicing bread, crushing a soda can. Then we have frying an egg, melting ice, using batteries, exploding fireworks. Last row is burning firewood, crashing cars, rusting chains, and chopping wood. When you're ready to see the answer, press play and it will be revealed. Great, so these are all the chemical changes, and you know they're chemical changes because what you start off with is not what you end up with. So think about it. The ingredients that you use to bake a cake is not the same thing as a cake. Batteries, you may be like, well, they're still batteries, but you know that they've changed because once they're dead, like they no longer work, they can't power your device anymore. So it cannot be the same thing, because when you started, they could power your device, in the end they couldn't. So there must have been some chemical changes there. All right, let's go ahead and move on. We talked about chemical versus physical changes. Now let's hone into chemical changes, which are also known as chemical reactions. There are several types of chemical reactions that you will know by the end of the year. The first 5 are probably the most relevant in the beginning of the year. So we're going to just look at the 5 types of reactions. The last one that we'll learn about later are redox reactions. We'll learn that later in electrochemistry. It's important to note that actually combustion reaction is a redox reaction, but it's difficult to tell what a redox reaction, most other redox reactions are, without some knowledge of electrochemistry. Okay, the first 2 we're going to look at is synthesis versus a decomposition reaction. So this is the first 2 types. Synthesis means to combine. And I want you to take a moment to look at the 3 reactions that are here and see if you notice what they have in common. Right, so you may have noticed that all of these have one product, and that's because in a synthesis reaction, we combine 2 or more reactants to form one product. And so that's how you can recognize something as a synthesis reaction, is that one product is formed from multiple reactants. And so that's what a synthesis reaction is. Decomposition, on the other hand, means to break apart. So I want you to take a look at the reactions for decomposition and see what you notice that they have in common. Right, so you probably noticed that in all cases, there's only one type of reactant. So even though there are 2 NH3s here, they're both NH3 molecules. And that's really a lot of times just for balancing. So we're starting with one type of reactant, and we'll break it apart to 2 or more products, and that's decomposition. So we can tell that decomposition and synthesis, they're pretty much reverse reactions of one another. Whereas synthesis, you form one product. Decomposition, you break one reactant down into many products. The next type of reaction we're going to look at is single versus double displacement. These reactions are also known as exchange reactions or replacement reactions because in both cases, something similar is happening where one or more reactants is exchanging or replacing another. Let's start off with single. So I like the word single because in a single replacement or exchange reaction, we have a single element as a reactant and we have a compound or a couple as a reactant. And what happens is the single reactant is going to replace one of the parties in the couple. So in this case, the magnesium metal will replace the copper cation and forming magnesium sulfate. And now the copper is off and single. Similarly, in this reaction, the chlorine is going to replace the bromide anion in sodium bromide. And so what happens is now sodium is hooked up with the chlorine and then bromide's off, bromine's off being the single person now. Let's look at the double exchange reaction. So this one is more Jerry Springer-ish, and I say that because it's more like two couples exchanging. So here we have silver nitrate couple and the potassium chloride couple. And what happens is the silver in the silver nitrate couple really wants to hook up with the chloride over there. And so silver and the chloride will go off together. And then potassium and nitrate wind up together as well. So they just sort of like switch partners. Let's take a look at the third example here. And this one is with sodium hydroxide and hydrochloric acid. And this is actually an acid-base reaction. And the products here are going to be a salt and a water. So for this type of reaction, I wrote water this way as HOH because it's easier to see that this is also an exchange reaction. Where in this case, it's the acidic hydrogen. So the hydrogen that goes first in the acid, that's going to hook up with the hydroxide anion. And the two, H and OH, forms H2O or water. And then the other product that comes from it is the metal will hook up with the anion over here, forming sodium chloride. So these are the exchange reactions, both single and double, where one or more reactants will replace another. The last type of reaction we'll look at is a combustion reaction. And a combustion reaction is one where we're burning something in oxygen. So one of your reactants for combustion will always be oxygen. I'll say that again. For a combustion reaction, one of your reactants will always be oxygen. And typically what we'll see for other types of reactants are hydrocarbons, things with carbons and hydrogens in them, or their derivatives. Now, the products of a combustion reaction are also well known. If it's a complete combustion reaction, and you're going to have to add this to your notes, complete combustion reaction products are CO2 and water, so carbon dioxide and water. And the reason why it's important to say complete is because combustion reactions can be incomplete, and in those cases, they produce carbon monoxide, CO. So how is knowing this useful? Sometimes what you'll be asked is you'll have a problem where they'll say, write the balanced equation for the combustion or the complete combustion of ethane. And so you would have to write the balanced equation, but all they gave you was ethane. So what you would have to know is, well, ethane's one of my reactants, and the other reactant is what for a combustion reaction? That's right, O2. So ethane plus O2, and then you would have to know that the products, if it's a complete combustion, the products will be what? Carbon dioxide and water. Great. So let's take a moment now to look at the CFU2, and you're asked to just label each reaction type. I want to point out that B is not balanced, and so I challenge you to balance B just for your own practice. When you're ready to see the answers to the CFU, press play and the answer will be revealed. Okay, so here are the answers. Take a look at the answers, and if you have any questions or whatever, please bring those to either my office hours or talk to me about it in class. We're going to pause this video now and then we'll begin part 2. So I'll see you guys there. Have a quality day.